So we have to study about arrays. How do we declare arrays? How memory is allocated for arrays, and how do you perform insertion, deletion, or searching operations on the arrays. Okay, so this is not new for you. Arrays is not new for you. I'll just quickly give some sample information about arrays. So we know that arrays in C programming are used to store or to store values of same data type. So if you write here int a of 5, it means you are going to read 5 values of type integer. Okay, so how do we initialize this? There are multiple ways of initializing. One way is directly write like this: int a of 5 equal to, in flower brackets, 1, 2, 3, 4 and 5. In the program itself you can write like this. Now when you are specifying the values in the program, the dimension is optional. So you can give here int a, empty brackets like this, as 1, 2, 3, 4, 5. Based on this count, based on this number of elements in the list in this array, it will decide the length of that is 5. Internally, automatically, implicitly it will do. It will calculate the size of the array, these 5 elements. Okay, suppose the other case you see, if I give int a of 3, a of 5, and if I give 1, 2, 3 alone, what about other two values? What about the other two values? What will happen? If I give a of 5, only 1, 2, 3 elements are given. What about other two values? See, in the program itself, we are assigning the values. I gave it as a of 5, and while I am assigning values, I gave only 1, 2, 3. Okay, when you do this, when you give only 1, 2, 3 like this, the remaining two values will be treated as zeros. Okay, remaining two values in that array will be stored as 1, 2, 3, and this two will be 0 like this. In this kind of assignment, the remaining two will be zeros. Okay, so this is how we read the values inside the program. We read it in the program. What if we want to read it using scanf statement? So we write some for loop for I equal to 0. If I want to read 5 elements, let n be 5. I'll write I less than n, I plus plus. We'll write here scanf percent d comma ampersand a of I. This way also you can read the array elements. Okay, now see the case. I have declared n value. I have declared an array int a of 5. Then I am writing for loop for I equal to 0, I less than 3 and I plus plus. Scanf percentile d comma ampersand a of I. See, the array size I have given as 5 elements, but I am reading only 3, that is 0, 1 and 2. I am reading only 3 elements. Okay, what about other 2 elements here? In the array, I will be storing those values as whatever. Suppose I am giving 1, 2 and 3. What about other 2 values? What about these 2 values? I am not reading them, but if I print them, what will I get as the output? Please tell. Yes, students, what will happen to the other 2 values? No, it is not 0. In this case, it is not 0. Okay, try to understand this once again. Okay, when you are reading from the keyboard, you declared it as a of 5, and if you are reading only 3 values, only 3 will be stored. Remaining 2 will be garbage values. They will be garbage values. But the case is that if you give something like this, int a of 5, in the program, if you're writing like this 1, 2, 3, and you are missing other two values, they will be 0, but not the through for loop. Understood the difference? Right? If you are assigning the values in the program, then if you miss some values, if you don't assign some values to the variables, it will be 0. But if you are reading using keyboard, right, that is the case. So this is about single dimension arrays, what we have to see. This is how it happens. Next, memory representation for arrays. So again, I am taking int a of 5. Assume int takes 2 bytes, or it is 4. Better to use 4, because most of the compilers, they say it as 4, right? So assume it takes 4 bytes. Now the memory allocation in your RAM, memory is allocated for this variable a of 5. So somewhere some block will be allocated. Continuous memory is allocated. Okay, right? What will happen here? So it will, since it is a of 5, it means 5 into 4, 20 bytes of memory is required. So 20 bytes of block will be reserved in your RAM to store these 5 values, each one occupying 4 bytes. And the address will be continuous. If the first element address is 100, then first is 100, then second one will be, if this is my array, like this, if I have, this will be 104, this will be 108, 112, and 116. Memory allocation is continuous. Okay, right? And once I give a of 5, once 20 bytes of memory is allocated, you cannot delete any memory allocation. You cannot delete this from the array. This is reserved in this block. You cannot delete a particular block. Only thing, you change this to 4 and compile once again. But once you give int a of 5, 20 bytes will be reserved. You store. You want to store 4 values, you store. You want to store 5 values, you store it. But if you want to delete some memory block, that is not possible to delete. Okay. So next, in arrays, something we talk about traversal. Traversal of array elements. Traversal of array element means going through each of the array elements. How we generally do? Suppose I have an array A with some values 1, 2, 3, 4, and 5. Indexing I have written here. I want to print only up to 3 elements, or let's take one more 5. Okay, I want to print only first half. So n value is 6 here. It means I have to take n value as only I have to go till 3. So how do we generally do? We do it in for loop only. For I is 0, I less than n by 2, I plus plus, printf, percentile d, comma I, a of I. Printf a of I. If I give it like this, then in this case, it will print only 1, 2, 3 as the output. If you want to print everything, you just put it I less than n. It will print every element. If you want to begin from 3 onwards, make this as 2. Okay, so you can do this. This way you can traverse. If you want to print them in reverse, change this for loop in reverse condition. Right? If you want to change this in reverse, you can do this in different case, like this. For I equal to n, I greater than 0, I minus minus, if you write, then it will begin, n minus 1 also you can take. So it will begin from 5, then 4, then 3, 2, 1, and 0. Okay, like this, I will put greater than equal to 0. Right? You can print in reverse, or it will print in this, any order, whichever you want. So we can traverse the elements of the array. Wherever you want, if you know the index, you can print its value. Right? Next is insertion operation. Can I have an array A? I declare it as A of 5. I'll just draw the memory block. I have here 10, 20, 30, 40, and 50. Okay. Now, let me take this as 6. Assume I have some empty block. I did not assign anything. Okay, this case you try to understand. Inserting a new value into the array. My question here is, my task here is, please insert 25 in between here like this. I want you to add a block here and insert a number 25 in between 20 and 30. In between 20 and 30, insert 25. How can we do this? Or suppose there is 60 also. I have assigned 60 also in that. There is no free space available. I want you to insert 25. Can I insert 25? No, because already we declared only as a of 6. So 6 into 4, this 24 bytes is allocated and fixed. I cannot insert something in between. If I want to insert, I can only replace the value. I can only replace, but inserting new elements in between the array is not possible. This is one drawback of array. In between, if I want to add a number somewhere, I cannot add it. I can add it by, if you want 25, you can add it by shifting this outside. So 60 will be lost. So 50 will come here, then 40, then 30, then you can put 25. You can move them towards right side. You can shift them towards right side, this side, this side, this side. You can shift it. Okay, right? But you cannot insert a new memory block because this is fixed size. Arrays follow static memory allocation. Once you give a of 6, it is fixed. We cannot extend it or increase its size. We cannot put there 25 in between. Okay, so this is about inserting an element. Any doubts in this insertion? Okay, let's see the next one, that is deletion. Deleting array elements. I have int a of 5. I have memory block here, some 10, 20, 30, 40 and 50. Okay, I want to delete 30 or I want to delete 10. I want to delete 10 from this array. Okay, one thing is very clear, we cannot delete the memory allocation. That will be linked with a only. I want to delete 10. I want to delete 10. Can we delete 10 here in this array? We cannot delete 10 because you can only replace. You may shift this 20 here, 30 here, 40 here. So array will become 20, 30, 40, 50 and 50. And you reduce this to n to n minus 1. You make your n value as 4. You update it like this. That way you can only print this 4. But the actual memory block has this 50 also. Because it is 20 bytes. This 20 bytes is reserved. This 20 bytes is reserved. So this is part of this block. We cannot delete any element. Only you can replace the elements. Like this 20, 30. This will still hold. But if you want to print and see, you can print like this and see. Using go up to n equal to 4 only, you can do that and see. In that case, this is possible. But we cannot delete the array elements. Right? Is it clear? Any doubts in this traversing, insertion and deletion of arrays? If I quickly summarize what we have seen. So, insertion is not possible. Deletion is also not possible, but we can replace values. Insertion also, I can only move the elements to right, move right and insert that new value. But memory block cannot be inserted in between and memory block cannot be deleted. Only values can be replaced about arrays. So these two are drawbacks of the arrays. In between I want to add, I am unable to add it. Right? So this is the drawback of the arrays. For this reason, we have to study some kind of a data structure which can overcome these drawbacks. So we will see that in further classes.